Welcome to another Technics repair video. This is an interesting one, and it's not one that I've seen exactly like this before. Normally we have what's called Runaway, and when you switch it on, the platter just spins fast. But this one is doing something different. So if we switch it on, it doesn't do anything. When we press start, it spins backwards. When we press stop, it spins backwards fast and will not stop. So that is the problem that we need to take a look at. I've got my scope set up, I've got the service manual for the turntable, so let's have a look at what the service manual flowchart says that we need to check with problems related to this. So this is the printout that I'm using. I will show this on the screen in better quality. So if we look down the troubleshooting, it says power switch doesn't operate. We know that's not the case. Doesn't rotate, it's not that one. Runaway operation, it's possibly runaway operation. Turntable rotates abnormally. Well, yeah, it's kind of doing that one as well, but abnormally would be kind of like wobbling, which happens when the pitch is bad or the pitch is not connected. So I think we need to look at runaway operation first. So the first thing it says is reference voltage circuit check test point 5 20 volt. So let's get something set up and work our way through this troubleshooting. Okay, I'm going to pop the platter off. As you can see, I already took the cover off there so that it saved time from me having to disassemble everything. In order to check these points, we need a ground point, and I normally use this point just there. So I'm just going to loosen that off a little bit and put this crocodile clip on. Just tighten it down. So that's now our ground point for testing, and we'll put that onto the ground probe of the multimeter. So we only need a multimeter at this point for checking test points. So let's get the multimeter in shot, and we want to be operating in DC volts. So the first test point that it says is test point 5 20 volt. Test point 5 is right just there. So it's on the end of R304. There we go. So I'm going to power it on, and we're going to measure test point 5, and it's 20 volt. So the first item on the checklist, 20 volt, is good. So next it says check voltage and waveform of IC201. And IC201 is the AN6680. So again, I'm referring to the service manual, and we have to check these various items, and it's difficult to check while it's on and you don't have a platter. So to start off with, we're going to check the items in the stop column, which is the state that it's in until you press start. So we're looking with the multimeter to just check these voltages: 2.5, 3.4, 9.8, 10, 8, and then these voltages down here. So let's do that. Again, we've got our test point on ground, we have our multimeter in shot. It's labelled on the board: pin 1, pin 12, pin 13, pin 24. So switch it on, and again we're using the items in the stop column. So pin 1 should be 2.5 volt. .6, so it's close enough. Pin 6 should be 3.4. So 1, 2, 3, 4, 5. 3.5, again close enough. And then we should have 0 volt, 0 volt, 9.8, 10, so that's a little bit low at 9.34. Pin 12 should be 0 volt. Pin 13 should be 0.2. 14, pin 15 should be 8. 2.5. So that's a bit low at 2.0. 5 volt. So although this says 2.2 and the manual says 0 volt, I've checked this on another turntable and that was the same, 2.2. So I'm going to say that this 2.2 is okay. And then again we have 7.8 volt when the service manual says 0 volt. But I've checked that on another turntable and that was the same. And then we have 5 volt, 0, 3, 3, and 2.8. So the voltages on that are okay, apart from voltage on pins 18 and 19. But like I say, I've compared that against another working turntable and they were actually okay. So the next thing that we want to check on this is the actual waveforms. So here we've got the waveforms. So we're going to use our oscilloscope to look at those. So just like before, we've got the croc clip for ground. Going to connect the oscilloscope up to the ground. And then we have the probe point at the end. So now I'm going to set up the picture from a second camera to show the output from the scope. Okay, so we've got our test probe ready. We've got it linked into ground on the deck. I'm going to go through the pins and look at the waveforms, and I'm just looking for the basic shape from the service manual. So pin 2 should be a square wave. Pin 3 should be very similar, slightly rounded. Pin 4 should be more of a sine wave. Pin 5 should be the same. Then we jump into pin 11. So that looks very similar. 12, 13, 14. So really, all of those pins on that chip match the service manual for the state that it's in at stop. So what I want to do next is I want to check the motor control chip, this one, and look what's happening on that. Okay, so looking at our service manual, IC 101, and we're looking at the stop column. So we've got pin 11. We'll check these because they've got waveforms for on and off. So 11, 12, 13, 14, 15, and 18. And let's look at what's happening with those. Okay, so IC 101, pin 10 should be 15 volt. And although it's a bit noisy, 5, 10, 15, it's actually a lot higher than it should be. So that's close to 20 volt. So let's check that with the multimeter. So yeah, so 19 volts when clearly it should be 15 volts. So do we have a problem with the voltage coming in? So let's check the 20 volt on these pins. So if we go pin 24, should be 1.7. Let's get that in shot. And 24 should be 1.7 and it's 1.8. And 23 should be 20 and it is indeed 20. Then we have 0.2. $20 again, and 20, and 20, and 20. So the pins coming, the 20 volt is okay, that's there. So we have an issue with the voltage on pin 10 being higher than it should be. And according to the diagram, pin 10 is going to ground with the capacitor at C105. So this is C105. Let's move that over a little bit. So we do indeed have 19 volts at C105, and then that's gone to ground. Let's take a look at the waveforms. So the ground is quite noisy. And what happens when I press start? Not a lot really. But then there's no platter on there, so there's nothing turning and there's no feedback coming from its position. Okay, so I think the first thing to do then is to change this chip. So that chip's getting quite warm. I mean, that's why there's a heatsink on there. So the quickest thing is that there's a problem with that chip. That chip handles the position of the platter. It's the motor driver, so it's doing strange things when we're turning it on, so that makes sense that there's a problem with that chip. So let's do that. Okay, I've got everything unplugged, so let's just take this out. Okie dokie, so we have the board out, resting on something so the components on the other side won't get damaged. Have an extractor with charcoal for the fumes, Amtech flux, solder braid, new solder, my TS100, and I also resurrected and pulled out the desolder gun, cleaned that and put a new tip on it. So we should be good to go. Okay, first I'm going to just reflow the pins. Okay, that's all the pins reflowed. A few micropoles of flux. We're not going too mad with that. And now we're going to use the gun. Yep, everything looks like it's just going to come off straight away. Let's move that. Pops out, no trouble. Okay, so now we need to find another one to put in. Okay, I removed this from another board. It was just the same that we already saw, so I didn't feel like we needed to do it twice. We can see on this corner of the silver screen that there is a corner, and that matches up to that corner on the chip. There we go. So that just wants to go just there like that. So again, let's use our pad, get it in shot. Okay, so just like any chip, I'm just going to do one corner while I hold it in place, and then the opposite corner. Now we can let go. Okay, so that's that reflowed. Let's quickly get a toothbrush and some IPA. Clean that flux off. Quick blast with hot air just to evaporate the alcohol off. Okay, we can get rid of the extractor, put the bearing back. The long screws that hold that in place. Connect up the start and stop, connect up the pitch, connect up the pop-up. Let's just put a tie wrap in there to hold that down so it doesn't catch. Moment of truth. Okay, let's see if third time is indeed lucky for me. So I've taken a chip off my own turntable that I definitely know works. So there's no question that this one is okay. So if this still doesn't work, it's not that chip. And there we go. So it's spinning forward. When I press stop, the brake is obviously on too high, so let's just adjust that. Maybe that's why it was doing strange things when we stopped it the last time. Pitch is okay. So there we go. We now know that if your platter spins backwards when you press start and then won't start properly, the problem is going to be the IC 101, and the easiest thing to check is for 15 volt on pin 10 on that side, and if it's not 15 volt, it's not, this chip isn't outputting the correct voltages. Now I want to show you the other common fault, which is where it does the runaway spin. And the runaway spin is this chip, this one just here, this transistor Q201. So I'm going to simulate what happens on that, and then I'll show you the fix. So we're looking underneath, and this is Q201. So if you have runaway, it'll be a bad joint. on one of these pins just here. Normally the first one, because the transistor wobbles and moves, that cracks. So we should be able to simulate a runaway by doing that. So that is basically the same thing now as a bad solder joint. So let's put this together and see if it does the classic runaway, and then we can fix it by simply soldering that joint. Let's give this a go. It should emulate what we call a runaway, where when you switch it on, it just spins really fast and there's no control over anything that's happening. So switch it on, it automatically spins and just keeps spinning. There was no power light, there was no strobe, no anything. So that is what we call runaway. So now let's fix that by sorting out that bad solder joint. So we want to check the pins on Q201, and like I say, you'll basically see a crack on those pins, but the easiest thing is to just resolder all 4 of them. So just a little bit of heat on there, a little bit of new solder. And that will fix any of the bad joints that's causing it to do the runaway. So let's put this back together and give it one last test. Power that up, light comes on now, spins correctly, stops correctly, speed selects OK. So I'm pretty happy that we have fixed the problem that I had with this turntable, which was it spinning backwards, not stopping. And I also showed you a common fault called runaway, where it spins with no power light as soon as you turn it on. Thank you for watching my Technics repair videos. They seem to be very popular. If you have a subject that you would like me to cover that I haven't done so far and that nobody else has done, please let me know and I will research it and see what I can do for you. Again, thank you for watching and see you again.